So our first topic, Circuit Topologies and DC Excitations, Introductory Concepts. So before that, let me share to you the quotation for today. So don't be pushed around by the fears in your mind. Be led by the dreams in your heart. So in this pandemic, di ba, we all have worries sa family, sa health natin. Tapos nagsabay pa yung new normal sa online class. So madami tayong worries. So, 'di ba, hindi natin alam kung kailan matatapos 'tong pandemic, hindi natin alam kung kailan matatapos 'tong gantong type ng klase. So, hindi lang yung mga students yung actually natatakot kasi pati yung mga prof, medyo nahihirapan kami. Actually, parang kahapon may nag-resign na naman. Ayun, so don't be pushed around by the fears in your mind. So, focus lang tayo sa goal natin. So, 'di ba yung goal nyo naman is anong goal nyo? Maging engineer, 'di ba? To be led by the dreams in your heart. So, sabi ko nga sa mga students ko, ngayon, engineering yung term for you guys, 'di ba? Sa mga students ngayon, engineering. So, by after ilang years, so yung ing sa dulo, unti-unti na yung mawawala. So, from engineering to engineer. So, that's your goal. Okay? So let me share to you this verse. So haven't I commanded you? Be strong and courageous. Do not be afraid or discouraged, for the Lord your God is with you wherever you go. So just keep the faith and always ask for God's guidance and you will be okay. So that's Joshua 1 verse 9. Now for this module, so by the end of this module, you should be able to understand the system of units, learn various circuit topologies like charge, current, voltage, circuit elements, power, and energy, solve problems related with the circuit topologies, and learn some practical applications of the concepts developed in this chapter. So yung course content natin, so of course we'll have some brief introduction about this course system of units, charge and current, voltage, power and energy, circuit elements, application, and of course the summary. Now let's have some introduction about the electronic circuits and components. So when we say electronic circuit, so that is a combination of electronic components and conductive wires interconnected in a way as to achieve an outcome. So marami tayong sample nito, 'di ba, yung mga electrical devices natin. So pag binuksan niyo yung mga 'yan, so it all composed of circuits. Yung mga electronic components natin, yung mga resistors, capacitors, inductors, transistors. So yun yung mga electronic components natin. So when these electronic components are combined by conductive wires and nagko-conduction ng current, so that is electronic circuit. So these circuits are interconnected in a way as to achieve an outcome. So it can be to achieve a current or voltage of a certain value, amplify a signal, or transfer data. Okay, so this is the basic input-output process ng sa circuit natin. So we have here an input, circuit, then output. So for example, 'di ba yung ano ba madaling example? So for example, yung microphone. So ano ba yung input natin doon? Yung voice, okay? So yung voice natin, yung input natin sa microphone, and then yung circuit inside the microphone will process the sound waves from our voice and then amplified it. So isa yun sa outcome na ine-expect ng circuit natin, amplifying that signal. Okay, so the purpose of an electronic component is to allow the designer to control the flow of current as to achieve a specified result or output. So we have here a simple electric circuit. So a simple electric circuit is just composed of a battery or a load and a lamp. So yung battery natin, that's the source, voltage source natin, and yung lamp natin yung output. And there is a connection of the wires, and there's a current that flows in these wires, so that is already a circuit. And we also have here a not so simple electric circuit where it is composed of different components. So, ayan, makikita nyo, marami na siyang components, mga symbols ng inductors natin, capacitor, antenna, ayan, may mga mixer pa, transistor, ayun. So, ganyan. So, kapag pag-aralan na natin yung circuit, kasi kapag nag-thesis na kayo, so mga ganito na yung mga makikita nyong or yung mga kailangan yung buuing circuit para mabuo yung thesis nyo, no? Okay. So let's proceed with systems of units. So International System of Units is adopted by the General Conference on Weights and Measures in 1960. So we have your length, mass, time, electric current, temperature, luminous intensity, and amount of substance. So yung mga unit niya, yun yung mga naka-SI unit. So di ba pag length, we have meter, mass natin, kilogram, time is second, electric current, that's the ampere, temperature is Kelvin, luminous intensity, candela, and the amount of substance is the mole. So, ito naman yung mga symbol natin. So, familiar naman kayo dito, no? Okay? Sabihin nyo, class, pag medyo mabilis, ha? Or may delay, something ganun. Sabihin nyo lang. So, except for current, all electrical and magnetic units are derived from the fundamental units. So, current is a fundamental unit. So, ito yung mga quantity na gagamitin natin throughout the course. So, we have electric current. So, current is a fundamental unit. At isa siya dun sa mga nasa SI unit kanina. Charge, voltage, resistance, and power. So, these units will be introduced later. So, yung unit niya, for electric current, we have ampere, charge natin, coulomb, voltage is volt, resistance is ohm, and power is watt. So, ito yung mga symbol naman niya. So, I think sa physics 2, tama ba na napag-aralan nyo na siya, no? Itong mga units na to. Physics 2?
Opo, ma'am.
Yes. Ayun. So, hindi naman siya ganun kabago sa inyo. Now, we have here scientific and engineering notation. So very large and very small numbers are represented with scientific and engineering notation. So meron tayo ditong SI prefixes. So ito yung mga ginagamit natin sa engineering. Kasi 'di ba meron tayong scientific notation, ito yung tinuturo sa atin nung high school pa lang. Meron ng scientific notation. Pero since engineering tayo, we're gonna use the engineering notation. So ang engineering notation is nakaganto siya. So 3, 6, 9, 12, 15, 18 by 3s. Okay? So yung 10 raised to 3 natin, kilo, 10 raised to 6, mega, 10 raised to 9, giga, 10 raised to 12, tera. Di ba? Para mga bytes natin, ba? Megabyte, gigabytes, terabytes. Okay? So kapag naman yung mga smaller prefixes natin, so we have 10 raised to negative 1 as deci, so yung decimal. 10 raised to negative 2, centi. 10 raised to negative 3, we have milli. Negative 6 is micro. Negative 9 is nano, si nano. Negative 12, pico. Yan, negative 15, femto, and negative 18, atto. Okay? So, example natin dito, we have 47 million. So, in scientific notation, we have 4.7 times 10 raised to 7. That's the scientific notation. Pag engineering notation, so move lang natin to the right. Okay? From 4.7, magiging 47 times 10 raised to 6 na siya para i-convert siya into engineering notation. So example natin dito, we have 0.000027. So in scientific notation, so 'di ba, move lang natin ng 5. So 1, 2, 3, 4, 5. So kaya siya nag-come up ng 10 raised to negative 5. Nasusundan po. Pag engineering notation naman, so move lang natin siya to the right. So magiging 27 times 10 raised to negative 6. Pag sa example number 3 natin, so ayan, 0.605. So, sa scientific notation, move lang natin ng isa, 6.05 times 10 raised to negative 1. Pero since kailangan natin naka-engineering notation, so kailangan naka-negative 2 siya, so move natin ng dalawa, 605 times 10 raised to negative 3. So, ano ba yung pag-convert? So, metric conversion natin. So, gagamitin na natin yung nasa table kanina. Okay, so hindi kasi tayo gumagamit ng mga ganito, yung mga times 10 raised to negative 6. So, ang pangit kasi niyan tingnan kapag nakaganito siya sa ano natin, 'di ba? Sa pag nag-compute tayo. So, mas maganda pag nagamit na natin yung mga units o yung mga prefix kanina. So, example natin, we have 0.47 mega. So, kapag big letter M, that's mega. Pag yung small letter M, so that is milli, okay? So, 0.47 megawatt is equal to 470 kilowatt. So, pansin nyo, ito yung larger number, tapos smaller unit siya. Okay, so sabi dito, when converting from a larger unit to a smaller unit, move the decimal point to the right. Ulitin po natin. When converting from a larger unit, so di ba ang larger unit natin, megawatts, to a smaller unit natin, kilowatt, so yung decimal point natin is move ng to the right. So 0.47, move natin ng tatlo papunta sa right para maging kilowatt. Malinaw po? So remember, a smaller unit means the number must be larger. Okay? So, when converting naman from a smaller to a larger unit, so move the decimal point naman to the left. So, example, we have 10,000 picofarad. Ano nga ba ang pico? Tanda ba? Ano yung picofarad kanina? Ano yung pico? Times 10 raised to?
Negative 12.
Yan, negative 12. So, 10,000 picofarad, that's equal to 0.01 millifarad. So, move lang siya ng ilan? 6, no? Move siya ng 6 kasi di ba ito is negative 12, tapos ito negative 3. So, smaller number, yung milli natin is larger unit. So, di ba kapag negative numbers, di ba, yung lower number siya yung mas mataas kaysa dun sa higher number kapag negative numbers. 'Di ba? Yung negative 3, mas mataas siya kaysa sa negative 12. Tama? Now, when adding or subtracting numbers with a metric prefix, so convert them to the same prefix first. So that's the rule. So for example, we have 10,000 watts plus 22 kilowatt. Yan. So we have 10,000 watt plus 22 kilowatt. So, yung 22 kilowatt, pwede natin convert into 22,000. Ayan, so same na siya, no? 10,000 plus 22,000 is equal to 32,000 watts. Okay, naglag ata siya. Alternatively, 10 kilowatt plus 22 kilowatt is equal to 32 kilowatt. So, yung 10,000 naman yung minove natin. Kinonvert natin into kilowatt. So, di ba, ang 10 times 10 raised to 3, yung 10 raised to 3 natin equal sa kilo. So, 10 kilowatt siya. Plus 22 kilowatt. So, that is equal to 32 kilowatt. Okay po? So, next example, so we have 200 microampere plus 1.0 milliampere. So, yung 1 milli natin, di ba, ito is equal sa 1.0 times 10 raised to negative 3. Tapos, yung 200 micro natin, that's equal to 200 times 10 raised to negative 6. Diba ito? 1 times 10 raised to negative 3. Diba? So kapag i-move natin siya into micro, move tayo ng tatlo to the right. So kaya siya naging 1,000. So 200 microampere plus 1,000 is equal to sobra yung sorry guys, sobra yung isang zero. That's 1,200 microampere. Pabura na lang sa nyo, ayan, 1,200 to. Okay? Ayan, so alternatively, 0. Ay yung 200 microampere natin. So kung i-move natin, gagawin natin siyang milliampere. So move naman siya papunta sa left. So kaya siya naging 0.200 milliamps. Okay, so mula dito, so move naman siya ng papunta sa left para maging yung micro natin magiging milliampere. So 0.200 plus 1.0 milliampere, that's equal to 1.2 milliampere. Nakukuha po ba?
Yes po, ma'am.
Ayun. So we have your selected key terms. So just a summary. Engineering notation, a system for representing any number as a 1, 2, or 3-digit number times a power of 10 with an exponent that is a multiple of 3. So yun nga. Milli, micro, nano, pico. Okay? So kapag patas naman, we have kilo, mega, giga, tera. Okay, so multiple of 3 ang engineering notation. Exponent natin, that's the number to which a base is raised. Metric prefix, a symbol that is used to replace the power of 10 in numbers expressed in scientific or engineering notation. Scientific notation, a system for representing any number as a number between 1 and 10 times a power of 10. Okay. May tanong po ba sa systems of units and scientific and engineering notation? Okay pa po ba?
Yes po, ma'am.
Okay, so let's proceed with charge and current. So charge is an electrical property of the atomic particles of which matter consists measured in coulombs. Okay, so yung charge natin, so dapat yung tandaan, ang unit niya is coulomb. In honor of, tandaan nyo ba kung kanino ipinangalan, kanino isunod ang unit ng charge? Kay Charles Agustin de Coulomb. Okay? So, yung sa kanya pinangalan yung unit ng charge natin. So, the following points should be noted about electric charge. So, the coulomb is a large unit for charges. In one coulomb of charge, there are 1 over 1.602 times 10 raised to negative 19. Ano to, class? Ano yung 1.602 times 10 raised to negative 19? That's the charge of? Yes, that's the charge of electron. So sa calcu, kung hindi nyo man siya tanda, nasa calcu din naman siya. That's constant 23. Kung hawak nyo yung calcu nyo, punta kayo sa shift. So click nyo yung shift tapos number 7. Kung 991 ES ha, yung gamit nyo, or 570 ES plus na calculator, so nandun siya. Shift constant, tapos type nyo 2, 3, lalabas yung letter E. Kita nyo ba? So pag in-equal nyo, nandun si 1.602176487 times 10 raised to negative 19. Kita nyo?
Yes po, ma'am. Yes po.
Yes po,
Ayun.
ma'am.
Yan. So, yung one column of charge daw natin, equal siya sa 1 over E or yung 1 over 1.602 times 10 raised to negative 19 or 6.24 times 10 raised to 18 electrons. Thus, realistic or laboratory values of charges are on the order of picocoulomb, nanocoulomb, or microcoulomb. So, mga malilit lang yung value niya. Okay? So, according to experimental observations, the only charges that occur in nature are integral multiples of the electronic charge E. So, di ba, lahat ng matter is composed of charges. So, lahat daw ng charges na nag-occur sa nature natin is just a multiple of electronic charge E. So, for example, yung bagay na to, meron siyang charge na 10 electrons or 10 times E, 10 times 1.602 times 10 is negative 19 coulombs. So, nandun lang siya. Integral multiple siya ng charge na to, ng E na to. Okay po? Then we have the law of conservation of charge. It states that charge can neither be created nor destroyed. So, it can only be transferred. Thus, the algebraic sum of the electric charges in a system does not change. Okay, so sa circuit natin, mamaya gagamitin din natin yung law of conservation of charge. Okay? So hindi siya can either be created nor destroyed. So yung charge natin nagte-transfer lang siya from one load to another. So ganun lang siya. So algebraic sum natin does not change. Now we have here the electric current. So tapos na tayo kay charge, proceed tayo kay current. So electric current is the time rate of change of charge measured in amperes. So this is the unit in honor of, tanda ba kaninong ipinangalan? Si
Andre Marie
Ampere.
Ampere.
Yes, si Andre Marie Ampere. Yan. So sa kanya yon. So we have here an electric current due to flow of electronic charge in a conductor. So, mapapansin nyo, class, this is from positive and this is from negative. The flow of current is papunta dito, while yung flow ng negative charges natin is opposite the flow of the current. Okay? So, ganun daw nabubuo yung current natin. So, positive charges move in one direction, while negative charges move in the opposite direction. So, this motion of charges, so nagkakaroon kasi ng friction yung positive and negative charges dyan. So, kaya nagkakreate yung ating electric current. So, it is conventional to take the current flow as the movement of positive charges. So, kapag nag-solve tayo, ang gagamitin natin is mula lagi sa positive. Mula lagi sa positive source. Okay? So, yun yung gagawin nating conventional flow ng current. So, that is opposite to the flow of negative charges. So, yung convention na to, it was introduced by Benjamin Franklin, isa American scientist and inventor. So, mathematically, the relationship between current I, charge Q, and time T is equal to I equal to dq over dt, or change in charge with respect to time t. So, where current is measured in amperes and 1 ampere is equal to 1 coulomb per second. Okay? So, di ba si charge natin kanina, siya si coulomb, and yung time natin, di ba, siya yung second. So, 1 ampere equals sa 1 coulomb per second. Okay? So, tatandaan nyo to. So, mula dito sa formula natin na I is equal to dq dt. So, rewrite natin siya dito. I is equal to dq dt. So, kapag isa-solve natin si charge q, so taas natin yung dt, I dt is equal to dq. So, di ba para mawala yung d or yung derivative, kailangan natin mag-integrate. No? So, we have integral of I dt dito. So, integral of I dt, that's equal to q. Already, integral ng dq. So, kaya na buo itong formula na to. So, yung charge natin, that's equal to integral of I dt from time t0 to t. Okay po? So we have a direct current. DC is a current that remains constant with time. So two types siya ng current. We have direct and alternating. So yung direct current natin, sila yung current na nagpo-flow kapag ang source natin is battery, cell, yun, yung mga DC lang siya, power supply, ganyan. Alternating current naman, a current that varies sinusoidally with time. So, ganito naman yung itsura ng alternating current. Direct current, so direct nga lang siya, so it's a straight line. Pag alternating, varies sinusoidally with time t. So, alternating current, yung mga kuryente sa mga ano natin, sa kuryente sa bahay natin. 220 volts, easy yan. Pag direct current, so yung mga battery lang siya. So we have here an example of computation. So how much charge is represented by 4,600 electrons? So sabi natin kanina, one column, saan nga siya equal? Dun sa properties ng charge. Saan equal ang one column natin?
1.608.
Sa 1 over E, di ba?
1 over 8.
Or 6.24 times 10 raised to 18 electrons. Tama? So, para ma-convert natin itong electrons into charge, so gawin natin lang yung conversion. So, 1 coulomb over 6.24 times 10 raised to 18. Sorry sa sulat. Ang pangit pala ng sulat ko dito. Tapos, multiply lang natin dun sa given na 4,600 electrons. So, di ba ito, magka-cancel ng electrons. Ang matitira natin is column. So, ilang column daw? So, pa-compute naman sa inyong calculator. So, we have 4,600 over 6.24 times 10 raised to 18. Ano magiging sagot?
2.87.
Naka ano to? Naka times 10 raised to 18. 18 to ah.
Ma'am, 7.37 times 10 raised to negative 16 po.
Ayun, so tama. You have 7.37 times 10 raised to negative 16. Ang unit natin is, ano unit?
Column.
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 Okay.
Column.
Columns. Ayan. So makikita din naman siya. Yun yung natira natin dito sa computation natin. And ang hinahanap kasi natin is yung charge. Okay?
Ma'am, question po.
Yes.
Ma'am, bakit po dun sa dun po sa binigay niyo po na module, negative 7.369 po yung, 37 po yung sagot.
Yun is ano naman siya. Kasi 'di ba, ang charge talaga ng electron is negative. So ito, yung magnitude lang naman siya. So okay lang din naman kung ilalagay nyo na negative siya. Kasi 'di ba, ang charge ng electron is negative talaga. Ayun. Okay po.
Okay.
Pero kapag tinanong lang naman how much charge, so magnitude, when it comes to magnitude naman, 7.37 times ano is negative 16. Okay?
Okay pa, ma'am.
Next example, so we have here a total charge entering a terminal is given by U is equal to 5t sine 4 pi t millicoulomb. So take note nyo yung unit natin, naka-millicoulomb siya. So calculate the current at 0.5 second. So paano nga i-compute to? So anong formula natin for current? I is
dq
equal
over
to
t.
Equals to dq over
dq
dt.
over dt. So ibig sabihin, d of 5t sine 4 pi t dt. So, the derivative natin to ngayon. Anong derivative ng 5t sine 4 pi t? Anong i-apply nating rule dito?
Product rule po.
Product rule.
Yes, product rule. So, anong product rule ng 5t sine 4 pi t?
5
5
sine
sine
5
4
sine of 4 pi
4
t
pi t
plus
20
25
20 pi kasi
20
5
pa
times 40 pi, no? 20 pi t
t
cosine
cos
of 4
4 pi
pi t. Nasundan po ba ng lahat? Nakita tayo doon? Yes. So, at t is equal to 0.5 seconds. So, ito, substitute lang naman natin siya dun sa nakuha nating equation. So, we have 5 sine of 4 pi times 0.5 plus 20 pi times 0.5 cosine of 4 pi times 0.5. Plus yung t dito, ilagay nyo siya sa loob ng parenthesis na ganun ha kapag tinype nyo siya sa calculator. Kasi 'di ba, ang 4 pi t is buong angle siya ni sine tsaka ni cosine. And dapat naka-radian mode. Okay, wag nyo pong kalilimutan na naka-radian mode kapag ang mga given natin is merong pi. Ito, 'di ba naka-pi siya. Naka-radian mode tayo dapat. So, ano magiging sagot natin dito?
31.42
Ayun. So,
milliamps.
31.42
Milliamp.
milliampere. Kasi,
Naka-microcolumn.
naka-millicolumn tayo. Okay po?
Ay, milli pala.
May tanong po ba? Na sundan po ba ang ating computation? So next example, determine the total charge entering a terminal between t is equal to 1 second and t is equal to 2 second if the current passing the terminal Si equal to 3t squared minus t ampere. So paano naman ang gagawin natin dito? So hinahanap natin si total charge. Ano yung formula natin for charge? Charge natin, di ba, si Q? Pag yung hinahanap natin, anong gagawin?
Q is equals to
Integral.
Integral of I dt from time 0 to time t. So may binigay tayong time na 1 second and 2 second. Okay? So, lagay lang natin siya sa formula. So, yung I natin equal daw siya kay 3t squared minus t. Yung t0 natin, that's 1. And yung time na isa natin is yung 2. So, limits natin from 1 to 2. Gawin natin dt. So, ano ba yung integral nito? 3t squared minus t. Ano yung integral?
t cube minus t squared
t
over 2
cube minus t squared over 2. Diba? Kasi yung 3t squared natin magiging 3t cube over t. So, cancel yung 3. Okay po? Nasundan yun? Diba? Ganun siya. So, cancel to. Kaya siya naging t cube. Okay? Limits natin from 1 to 2. So, substitute lang natin. So, we have 2 cube minus 2 squared over 2 minus 1 cube minus 1 squared over 2. Ano magiging sagot? Q natin equal kay
5.5 column.
5.5 column.
5.5 columns. Ayun. Sundan po ba? Okay. So, try this out. So, ito, gusto ko i-try nyo naman siya. The total charge entering a terminal is given by Q is equal to 10 minus 10 e raised to negative 2t millicoulomb. Calculate the current at 0.5 second. Sige, try nyo muna siya on your own. Tapos sabihin nyo sa pag nakuha nyo na yung sagot, saka natin siya sasagutan. May nakakuha na ba ng sagot?
Ma'am,
Hmm.
7.36, ay, 36.
Ayun. Yun, may nakakuha na ng sagot. So, sige, compute natin. So, calculating the current, di ba, ito lang ay I is equal to dq dt. Okay? So, the derivative lang natin yung given na 10 minus 10 e raised to negative 2t dt. So, ano derivative nito? Ba negative 10 times negative 2 e raised to negative 2t. So, equal siya sa 20 e raised to negative 2t. Then, at t is equal to 0.5 second, we have 20 e raised to negative 2 times 0.5. Ang mga sagot, 7.36 milliampere. Yun din ba nakuha ng iba?
Yes po.
Ayun. So, ganun lang naman siya. Kapag current yung hinahanap natin, so magde-derivative lang kayo. Kapag charge naman, so yung integral naman siya. Then, substitute the given time. Okay po? Malinaw po ba? May tanong ba sa charge and current? And syempre, wag niyong kalilimutan yung unit natin. Pag current, yun ay ampere or yung A. Kapag naman charge, yun ay coulomb. Okay po? So, yan. Huwag niyo kalilimutan. May tanong ba so far, class? Okay. So, wala naman. So, let's proceed with voltage. So, voltage or also known as potential difference is the energy required to move a unit charge through an element. So, unit niya is volts. So, the voltage between 2 points, A and B, in an electric circuit is the energy or work needed to move a unit charge from A to B. Mathematically, VAB is equal to the change in energy over dq or the charge. Okay? So, yung voltage, siya yung parang nagpo-push dun sa charge natin para mag-move from point A to point B. Okay? So, yung energy natin dito, that's measured in joules. And yung charge natin, syempre, coulombs pa rin. So, ibig sabihin, yung 1 volt natin, that's equal to 1 joule per coulomb. Or, yung joule din kasi natin, that's equal to 1 Newton meter. Kasi 'di ba yung saan ba tawag dito? Saan pa bang unit ang joule? Naalala niyo pa ba in physics? Saan ginamit ang joule?
Work
Yes,
po.
sa work. Sa work siya ginamit. No, anong formula ng work?
FT.
Work is equal to FD. Force times displacement. And 'di ba yung unit ng force natin is Newton? 'Di ba ito? Newton. Tapos yung meter naman is the unit for displacement. So, kaya equal yung 1 joule per coulomb natin. So, 1 Newton meter per coulomb. Okay? So, yung mga ganitong derivation, maganda alam nyo din siya. Para kapag ganito yung mga given, naka-joule lang, naka-coulomb, alam nyo na, makukuha pa rin natin yung voltage pag sila yung mga given. Okay? So the plus and minus signs are used to define reference direction or voltage polarity. The VAB, so yung VAB natin dito, it can be interpreted in two ways. So first one, point A is at a potential of VAB volts higher than point B. So, yung A daw natin is higher yung potential niya than B. Kaya mas nauna yung A dito. Okay? VAB siya. Yung number 2 naman, potential at point A with respect to point B is, ba't ganun yung sulat ko? Ayan, check ko mamaya. So, it follows logically that in general, yung VAB natin, kapag ganito yung convention naming niya, that's equal to negative BA. So, pinagbaliktad yung BA dito. Nakuha niyo yung convention class. Pag yung potential daw sa A natin is higher than yung potential sa B natin, yung naming convention niya is VAB. Pero equal lang din siya kay negative BA. Kasi nga 'di ba, kung mataas yung potential dito at negative to, so parang magbabaliktad lang 'yon. So same lang yung meaning niya. So like electric current, a constant voltage is called a DC voltage. So 'di ba kanina meron tayong DC current and meron tayong AC current. So sa voltage ganun din, meron tayong DC voltage and AC voltage and is represented by V. Malaking V kapag DC voltage. Whereas a sinusoidally time-varying voltage is called an AC voltage and is represented by V na maliit. Ayan. Or minsan ginagamit yung V of T. V of T. Kasi with respect to time T, di ba ang ating AC voltage? Kasi nagbabago siya with respect to time. So, a DC voltage is commonly produced by a battery. So, ito sinabi ko na kanina. AC voltage produced by an electric generator naman siya. So, for example, meron tayo ditong 9 volts. So, ito, pag binaliktad siya, negative 9 volts. Nandito yung negative. Okay? Next po, so power and energy. So to relate power and energy to voltage and current, we recall from physics that power is, ito yung definition natin mula pa sa physics, time rate of expending or absorbing energy. And the unit of power is watts. Okay, so we write this relationship as P is equal to the change in energy with respect to time T. Okay, so where P is the power in watts. So yung energy natin, joules. Yung time natin is seconds. Okay? So ito, 'di ba, yung P natin, so mula dito 'yon. Tapos, 'di ba kanina sabi natin, joule per coulomb yung V, 'di ba siya yung V? Si joule per coulomb, si D, W over dQ. Tapos yung dQ dt natin, sino to? Siya 'di ba si current? So, ibig sabihin, ang power natin equal siya kay V times current. Kasi ito, di ba, maka-cancel to, maka-cancel to. So, dW dt, ito rin yun. Nakuha po? So, it is derivation ng formula ng power. Ayun. So, we have passive sign convention satisfied when the current enters through the positive terminal of an element and P is equal to VI. So, dito sa A natin, yung current natin, nagmula siya sa positive. So, for example, meron tayo ditong source. So, pumasok siya, ibig sabihin, yung P natin dito is positive VI. Okay? Nagmula siya sa positive. Pero kapag paalis siya dun sa, sa load natin, papunta siya sa positive, so equal naman siya sa negative VI. Susundan po. Pero ito, so 'di ba, from positive pumasok siya. Pumasok si 3 ampere. So, meron tayo ditong 4 volts. Tapos, dito, lumabas siya, pero lumabas naman siya kay negative. So, ibig sabihin, kung lumabas siya kay negative, pumasok pa rin siya ng galing sa positive. Kaya siya, positive 4 volts pa rin. Nakukuha po ba?
Yes po,
So,
ma'am.
yung power natin, class, pag positive, that's absorbing power. Kasi nga, galing siya dito sa positive, papasok siya sa load natin, absorbing power. Kapag naman palabas, so nagsusupply siya. Supplying power naman siya. So dito, since same naman yung ano natin, yung voltage natin, tsaka yung current, so same yung power natin. P is equal to 12 watt. Ito is nagbago lang yung itsura niya, pero 'di ba same pa din. Ito, pumasok yung current natin from positive, pumasok sa load natin, 4 volts siya. So, 12 watts pa rin siya. Ito, pinakita lang yung current natin lumabas sa negative, pero dahil lumabas siya sa negative, ibig sabihin, pumasok pa rin siya galing kay positive. So, ibig sabihin, power natin, 12 watts pa rin. Positive. Okay po? So, yung power absorbed, positive power absorbed, that's equal to negative power supplied. Kasi 'di ba ang power supplied natin naka-negative, 'di ba? So negative tapos negative BI, parang ganon. So negative negative BI, that's equal to positive BI pa rin. So kaya siya ganon. Ayan. Power absorbed equals sa negative power supplied. Nasusundan po ba?
Yes po, ma'am.
Okay, so in fact, the law of conservation of energy must be obeyed in any electric circuit. So, ito nga sabi ko kanina, di ba meron tayong law of conservation of charge. So, dito meron tayong law of conservation of energy na sinusunod sa electric circuit. So, for this reason, yung algebraic sum of power in a circuit at any instant time must be zero. So, ayan. Summation ng power natin sa circuit equal lang sa zero. So this again confirms the fact that the total power supplied to the circuit must balance the total power absorbed. So from equation na to, the energy absorbed or supplied by an element from time t0 to time t. So equal lang siya sa integral ng p dt or yung p natin, 'di ba, equal lang siya sa VI. So sinubstitute lang siya dito. So, same lang din yung pag-derive kanina ng ano, 'di ba, dWdt. So, itataas lang natin yung ano, yung dt tas magi-integrate. So, kaya lang na form yung formula na to. Okay po? So, energy, capacity to do work. So, hindi naman parang ganito pa rin yung laging meaning ng energy, no? That's the ability or the capacity to do work and is measured in terms of joules. So, meron tayong conversion. Electric power utility companies measure energy in watt-hours or WH, where 1 watt-hour is equal to 3,600 joule. Ayan, so tandaan nyo yung conversion din natin na to. So we have here an example. So an energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. So if 2.3 kilojoule is given off in the form of light and heat energy, so calculate the voltage drop across the bulb. So paano natin isosolve to? Ano muna nating makukuha? So, meron tayong, sige, lagyan muna natin yung given. So, pag sunod natin yung given, ano mga given natin, class? Meron tayong
2
current,
amperes,
si 2 ampere. May time tayo
10
na 10
seconds,
seconds. And ano si 2.3?
W,
Yeah, sa W. 2.3 kilojoule. So, para makuha natin yung voltage drop, ano ba yung formula ng voltage drop natin? Or yung B, di ba? The B natin. Sabi natin kanina, anong formula to?
delta W,
Delta W over
over delta
delta,
charge Q.
yung charge Q. So, ibig sabihin, kailangan muna natin kunin si charge Q. Tama? Para natin makuha si charge Q, di ba si I natin equal kay dQ dt, di ba? Or change in Q over change in time. So ito is I delta time equals sa delta Q. May given tayong I, tama, 2 ampere. Tapos may given tayong time which is 10 seconds. So, yung delta Q natin equal kay 20 coulomb. So, meron tayong charge. So, sasubstitute lang natin siya dito. So, yung delta W natin, that's 2.3 kilojoule over yung nakuha nating delta Q which is 20 coulomb. So, ano magiging sagot dito? B natin, san equal?
115 volts.
115 volts. Ayan. So, ganun
Ma'am,
lang siya.
may multiplier po ba, di ba yung 2.3?
Oo. Di ba yung 2.3, pag nilagay nyo siya sa calculate, that's 2.3 times 10 raised to 3. Oo. So, pag ginompute nyo, 2.3 times 10 raised to 3 divided by 20. So, that's 115 watts. Na-type nyo siya sa calcu, class.
Yes, ma'am.
Yan. So, eto, basta pag mga nasa given na kasi nakaganito na siya eh. Yung gumagamit na siya ng metric conversion. So, kailangan tandaan nyo yung nasa table. Yung paggamit ng kilo, milli, micro, nano, mga ganan. Para kapag tinype nyo siya sa calcu, ano na siya. Naka-convert na siya into times 10 raised to kung ano man yung exponent na kailangan. Okay pa?
Yes po, ma'am.
Okay, next. Oops. So, example number 2. So, find the power delivered to an element at t is equal to 3 millisecond if the current entering its positive terminal is I is equal to 5 cosine 60 pi t ampere and the voltage is yung A natin V is equal to 3I. Then B natin 3 di dt. So, simulan natin sa A. So, paano nga i-compute ang power natin? Anong formula ng power natin?
BI.
So, VI. So, given tayo ng V, sabi dito, ang V daw niya is 3I. So, multiply natin kay I. So, ibig sabihin, ito ay 3I squared. Pero ang I natin na given is, ito, 5 cosine 60 pi t. So, substitute natin, 5 cosine of 60 pi t squared. So, we have 3 times 5 squared,
15.
75. Kasi 5 squared ay 25 times 3, 75. And we have cosine squared of 60 pi t. Now, ang tinatanong, at t is equal to 3 millisecond. So, at t is equal to 3 millisecond. P is equal to, substitute lang natin, 75. So, ito, pag tinype nyo siya sa calculate, ilagay nyo cosine of 60 pi times 3 times 10 raised to negative 3 kasi naka-millisecond siya, di ba? Then, saka nyo siya i-square. At syempre, huwag nyo kalilimutan na dapat naka-radian mode. So, ano magiging sagot dito?
Fifty-three point 47.
53.47 o 48?
Wait lang po, ma'am.
47. Sige, kung yun naman nakuha nyo eh. 53.47 watts. Ayan. Nakuha po ba? So, yung iba kasi nagkakamali dito sa paglagay nung time, sa pag-substitute na yung time. So, huwag kayong magkakamali sa sa paglalagay ng parenthesis pag nilalagay na siya sa calculator. Kasi minsan na ilalabas nila to. Tapos, di ba, naka-square. Naka-square si cosine. So, wag nyo rin siyang kalilimutan pag nilagay natin siya sa calculator. Okay po? Okay na ba sa A?
Yes po.
Yan. So, proceed tayo kay letter B. So, we have B is equal to VI ulit. Yung V naman natin dito is 3 di dt times yung I. So, 3 times derivative ng 5 cosine of 60 pi t times 5 cosine of 60 pi t. So, ano derivative ng 5 cosine 60 pi t? Ang derivative ng cosine,
Negative sign.
negative sign. And kailangan meron tayong 60 pi. So,
Pi.
lagyan natin negative sign, 60 pi t times 5 cosine of 60 pi t. Ayan, kasya. So, ilan to? 3 times 5 times 60 pi times 5. Ilan yun? Negative
4, 4, 4, 500.
4,500.
500.
So, copy lang natin si sin 60 pi t cosine of 60 pi t. And substitute natin at t is equal to 3 millisecond. So, P
Ma'am,
natin, substitute. Yes.
meron pa pong pay sa after po ng 4,500.
Ay, ayun. Ayun pala. Ayun. Sige, thank you. Ano magiging sagot natin? Pag sinubstitute na si 3 millisecond, substitute nyo na. Yung t natin dito, 3 millisecond. 3 times 10 raised to negative 3. Ano magiging power?
Negative
Negative.
6,395.85 watts.
Or gamit tayo ng metric conversion, negative 6 point, ano na lang siya? 3, 9, anong kasunod?
6,396.
6 kilowatt. Gagamitin natin yung kilo, okay? Sa engineering notation nga yung gagamitin natin pag nagsosolve tayo, okay? So, kung may mga kayong sagot, yan, negative 6,396. Click nyo lang yung ENG sa calculator. So, yung ENG na function yung nasa tabi ng RCL. So, pag kinlik nyo yun, magko-convert na siya agad into engineering notation. So, para sa atin yung function na yun para sa ating engineering. Okay? Na-try nyo yung ENG.
I.
Hmm? Yung ENG function sa calcu. Click nyo lang pag nag-compute kayo, tapos may nakuha na kayong sagot, click nyo yung ENG para naka-engineering notation na siya agad. So, kapag nakalagay times 10 raised to 3, ibig
Okay na po.
sabihin, kilo yon. Okay? May tanong po ba? Okay naman. Hindi naman masyadong mabilis.
Okay lang po, ma'am.
Okay.
Minsan ma'am nagde-delay yung screen, minsan nahuhuli po.
Ay, ganon. Sige. Pero okay naman natapos
Opo.
naman ba yung pag-compute sa screen? Okay? Okay, sige.
Opo.
Ay. Oh, may mga
Hindi
delay
lang
lang
po,
talaga
ma'am.
minsan. Mm-mm.
Doon lang po nahihirapan sumabay.
Saan? Kapag
Pag
may
delay po
delay,
sa
no?
screen.
Oo.
Minsan
Sige.
ma'am, sinasabi niyo na yung sagot, nasa given pa lang po yung nasa screen.
Ay, talaga.
Sa signal po ata yun ma'am.
Baka nga. Sige, may ano naman siya, may naka-record naman yung ating discussion. So, pwede nyo siyang i-review ulit. No? Siguro naman pag na-record to, sabay naman siya. Tapos, try ko rin siyang gawa ng video para accessible din siya kahit sa YouTube.
Sige
Okay.
po.
Subscribe nyo lang yung channel ko. Box nag-promote. Okay, so example number 3,
Dito
we
lang po.
have How much energy does a 100-watt electric bulb consume in 2 hours? So ito madali lang. Ano yung formula natin for energy? Double natin equal sa power times time, no? Pero yung time natin, ano dapat yung unit ng time? Ang unit ng time natin dapat naka seconds. Okay, so may given tayo na power. Power natin 100 watt and yung time natin is 2 hours. So convert natin yung 2 hours into seconds. So 60 minutes, meron tayong 60 minutes into 1 hour. Tapos in 1 minute meron tayong 60 seconds. So, ilan to? 100 times 2 times 60 times 60, that is equal to, saan siya equal?
Seven
700,
thousand
7,200.
200.
720,000.
720,000 or click yung
20,000.
ENG. Click nyo yung ENG. 720
Times 10.
Joule
kilojoule.
pala.
Diba, naka times 10 raised to 3 siya. So, kapag sinulat na natin, kilo na siya. Okay?
Ma'am, question po.
Yes.
Letter I yung nalabas po sa akin kapag pinindot ko po yung ENG.
Letter
Mali po ba
I.
ako? Yung I po na maliit. Ba't ganun?
Opo, ma'am. Pag
Ay,
Yung sagot po, pinindot ko po yung ENG tapos nag-times lang po siya sa I.
baka nasa complex mode ka. Punta ka sa, ano lang, sa mode,
Simplified
tapos
mode.
click mo lang yung 1 comp. Yung number 1 lang. Kasi baka nasa complex ka, kaya nagle-letter I. Okay na? Check mo.
Opo. Ay, opo.
Tama na, naka-complex mode ka.
Ay,
Ayan,
po,
so
tama.
pag naka 720,000, pag kinlik mo na si ENG, lalabas 720 times 10 raised to 3. At yung times 10 raised to 3, susulat na natin siya as kilo. Okay po?
Yes po, ma'am.
Yes, ma'am.
Ayun. So ito, equal lang din naman siya sa, 'di ba? Isa pang unit ng energy natin is yung watt hours. So pwedeng 100 watt times 2 hours naman siya. So 200 watt hour. So ano nga yung conversion kanina ng watt hour to joules? 1 watt hour is how many joules?
3,600.
3,600.
3,600 joules or 1 watt hour. So, ganun din, magiging sagot natin 720 kilojoule. So, ito, kapag ang hinihinging sagot naka watt hour lang, so pwede nang hanggang dito. Pero kung ang hinahanap natin is naka kilojoule, so ganun. Ano yung sabi? Hindi ko nabasa yung sinabi. Hindi ko nabasa yung comment. Ay, yung nasa chat. Okay na po. Next. So, try this out. Ayan. So, try nyo na ulit. Find the power delivered in an element at T is equal to 5 millisecond if the current is I is equal to 5 cosine of 60 pi T and the voltage is V is equal to 2I. Sa letter B natin, 10 plus 5 integral of I dt. Okay. Try nyo muna. Sabihin nyo sa akin yung sagot. Pag tama, saka natin susolve. Anong sagot sa A? May nakapag-solve na ba?
5.88. Mali po ba?
Check mo ulit. Sige ko nga. 5 millisecond yung time natin. 5.
3.45 po.
Hindi pa. Isa pa. Check mo yung yung parenthesis. Baka dun lang nagkakamali. 41. Hindi 41 point,
53.48 watts po.
Hindi. Ang formula natin, class, is P is equal to VI. So, yung given natin, yung A, V is equal to 2I. So, 2I times I. Ano mo ko ang sagot?
9.998 volts po.
Ba't iba nakukuha nyo?
50 po.
Check nyo yung baka sa pag-type. Naka-region mode kayo, class? Dapat naka-region mode. Ayan, naka-region mode naman.
0.69098 po.
Hindi. Hindi. Check mo, check. Check mo ulit sa calcu.
17.27.
Ayun. Sino yun?
17.27.
7.27 po.
Ayun, 17.27 watt. Sige, solve na muna natin si letter A. May nakakuha na. So, di ba ito, P is equal to VI. Yung V daw natin equal siya sa 2I. So, ito, 2I times I. So, we have 2I squared. So, 2, yung I natin, ito, 5 cosine of 60 pi t. So, squared natin. And at time t is equal to 5 millisecond. So, P natin is equal to 2 times 5 cosine of 60 pi times 5 times 10 raised to negative 3. Ito, enclose nyo yung buong yun, ha. Nasa loob ng parenthesis yung buong 60 pi times 5 times 10 raised to negative 3. Tapos saka nyo siya is square. Okay? So, may makuha kayong sagot dyan na 17.27 watts. Sige, try nyo siya. Sa mga hindi nakakuha ng 17.27 watts, try nyong ilagay, ay ganito yung gawin sa calcul nyo.
Okay po, ma'am.
Nakuha na? Sa kayo nagkamali
Oh.
kanina.
Ba po, kinulang ng parenthesis.
Opo, may parenthesis po.
Oo, dun nga. Kasi pag nagkamali kayo ng parenthesis dyan, magbabago yung sagot. Kunyari ito, nalagyan nyo ng parenthesis dito. So, parang lalabas na, yung 60 pi lang yung angle ni cosine. Tapos, nakamultiply yung 5 kilo kay 5. 'Di ba? Parang ganun yung lalabas sa kanya. So, careful kayo dun. Okay? So, sa letter B, anong nakuha niyong sagot sa letter B? May nakakuha na ba ng sagot?
Negative 3556.46 po. Ba?
Check mo yung ano. Ito, nakabuo dapat siya na multiply dun sa I natin. Kasi 'di ba VI to? Baka hindi mo nalagyan ng ano, ng parenthesis dito sa unahan. Check mo siya. $20-something lang yung sagot. May clue.
Ma'am, ano po? 29.7 watt.
Sige, tingnan natin. Malapit eh. Sige. Check natin. So, P is equal to VI. Yung V daw natin is, gawin natin 10 plus 5. Integral ng I dt times I natin is 5 cosine of 60 pi t. So, this is 10 plus, ano integral ng I dito? 5 I squared over 2 lang, no? Tapos, limit natin is 0 to 5 millisecond. Times 5 cosine of 60 pi t. So, ito class, dapat nakumultiply itong buo kay I natin, which is 5 cosine 60 pi t. Okay? So, ba nalimutan yun. Tapos, substitute na natin at time t is equal to 5 millisecond. So, we have 10 plus 5 times 5 millisecond squared over 2. Then 5 cosine of 60 pi times 5 millisecond. So, ano magiging sagot natin? Ano yung nakuha nyo dito? Ay, sige. Pa-calcu naman. 29 point something. Iba kasi nakuha kong decimal point. Anong nakuha nyo, class?
29 point
39.
29.39. Opo.
Ayan, 29.39 watts. Ayan siya. Okay. Ayan, nakuha din ba ng iba?
Yes, ma'am.
Ayan, okay tayo na. So, may tanong ba sa power and energy? Konti na lang. May tanong ba sa, so far? Okay naman?
Yes po, ma'am.
Okay, sige. So, we have now circuit elements. So, circuit analysis is the process of determining voltages across or the currents through the elements of the circuit. So, later kapag sa mga susunod nating topic, so we'll be dealing with circuits na, yung mga circuit elements ilalagay na natin sa circuit and we'll be solving voltages and current. So yung pag-solve nun, that's the process of circuit analysis. So there are two types of elements found in electric circuits. We have passive and active. So pag sinabing active, it is capable of generating energy while a passive element is not. So examples ng mga passive elements natin are resistor, capacitor, and inductor. So ito yung mga resistor natin. Yan, ito mga capacitor yan. Ito resistor, capacitor, Ito, capacitor din to. Tapos ito naman yung mga inductor natin. So, kung na-try nyo na di ba yung mga sirang charger class, pag tinanggal nyo yung case na makikita nyo, may maliit dyang circuitry. So, hindi nawawala itong mga components na to doon. Lalo yung capacitor. May makikita kayong mga circuit elements. So, yun na yung mga passive elements siya. Typical active elements naman include generators, batteries, and op-amps or the operational amplifier. So our aim in this section is to gain familiarity with some of these active elements. So the most important active elements are voltage or current sources that generally deliver power to the circuit connected to them. So ito yung mga So, meron tayong two kinds ng sources. Independent tsaka dependent. So, an ideal independent source is an active element that provides a specified voltage or current that is completely independent of other circuits. So, pag sinabing independent, wala siyang pakialam dun sa behavior ng other elements. So, independent nga siya. So, ito yung mga symbols niya for independent voltage sources. And ito yung mga source na kalimitan gagamitin natin throughout the discussion. So, mga independent voltage sources lang. So, used for constant or time varying. So, kapag may involved na time, so ganito yung tsura niya. Pag naman constant voltage, so yung DC, diba, ganito yung symbol for battery. Okay? So, pag sinabi namang dependent or a controlled source, so it is an active element in which the source quantity is controlled, controlled by another voltage or current. So, example natin dito, so, dependent voltage source, diamond siya. Diamond yung yung itsura niya. So 'di ba yung independent natin bilog. Kapag minakita ko yung diamond sa circuit, that is an example of dependent source. So pag may sign yan, positive negative voltage 'yon. Pero kapag arrow, yun ay current naman. So same lang din kapag sa DC. Kapag bilog, kapag may nakita ko yung bilog na nakaganan, current source yun na DC. So, since the control of the dependent source is achieved by a voltage or current of some other element in the circuit, and the source can be voltage or current, so it follows that there are four possible types of dependent sources. So, pwede daw magkaroon ito yung mga combination ng dependent sources natin. So, pwedeng voltage-controlled voltage source. So, nakadepende to kung ano yung kinokontrol niya. So, ito, pag voltage source siya, tapos voltage control din, BC, BS. Pag current naman yung kinokontrol, pero voltage source, CCVS naman. Pag voltage control, current source. So, apat na combination ng dependent sources. So, example natin, ito. So, di ba pag diamond, so, dependent source siya, no? So, yung 10i natin dito, ano nga yung sabi ko kanina, kapag may positive, negative, type siya ng
voltage
source. Pero, kung mapapansin nyo, ang nakasulat dito, 10i. So, ibig sabihin, controlled siya nung current na to. So, saan siya papasok dun sa 1 to 4?
current
Anong
controlled
number?
voltage 2
Yes, si number 2. Current controlled voltage source. Kasi, voltage source, ito, di ba, voltage source. Tapos, controlled by current. So, current controlled voltage source. So, ganun siya. Pero pag kunyari, ang nakalagay dito ay, kunyari, 30 volts. Tapos, may nakalagay ditong positive, negative, may nakalagay na V. So, ibig sabihin, ano naman siya? Voltage controlled voltage source. 'Di ba kasi voltage source pa rin naman siya. So ganun lang. Tapos kapag kunyari, meron tayong nilagay pa dito na uh, pagtabi na lang natin. Kunyari may nakalagay ditong ganyan. Tapos may nakalagay na 3i. So ito, current source naman siya. Tapos, nakadepende kung ano nakalagay sa kanya kung current or voltage controlled. Pero pag nakalagay 3i, 'di ba, current, so ito is current controlled. Pero kapag ang nakalagay sa kanya is, nyari, 30B. Tapos, may V kayong makikita sa circuit. So, voltage controlled current source. Nakukuha po ba yung logic niya?
Yes po, ma'am.
Ayun. So, ganun lang naman siya. Ay, may nakalagay palang ano. Ayan. Current controlled voltage source. Ayun. So, application. So, meron tayong application ng mga circuit elements na pinag-usapan natin kanina. So, one important application of the motion of electron is found in both the transmission and reception of TV signal. So, isang application niya yung sa TV natin. So, at the transmission end, there's a TV camera, reduces a scene from an optical image to an electrical signal. Scanning is accomplished with a thin beam of electrons in an iconoscope camera tube. At the receiving end naman, the image is reconstructed by using a cathode ray tube located in the TV receiver. So meron tayong at the transmission end tsaka at the receiving end kung paano nagtatransmit yung signals from the tawag dito, from the TV station papunta dun sa mga TV natin sa bahay. So ganito daw yung itsura nung nasa loob ng TV natin. So yan, just one of the application. Pero 'di ba sa sa daily activities naman natin, halos lahat tayo gumagamit ng mga electrical devices. So yung mga yon, lahat is may flow ng current, may flow ng charges, may flow ng electrons, no? Ayan. So ito, nag-specify lang sila ng application using an electron beam sa TV picture. So supposedly we have electron beam TV picture tube carries 10 raised to 15 electrons per second. So as a design engineer, determine the voltage needed to accelerate the electron beam to achieve 4 watts. So ano daw hinahanap natin dito? Hinahanap natin si voltage, no? So 'di ba, may given tayo na 10 raised to 15 electrons per second. Ano nga yung charge ng electron natin? 1.602 times 10 raised to negative 19 coulomb, no? So, gawin natin, 'di ba, yung charge natin, gawin natin equal sa number nung electrons times yung charge niya. So, 'di ba sabi natin sa isa sa mga property ng charges is lahat ng present na charges sa nature is just an integral multiple nung electron natin. So, kung meron siyang certain number of electrons, so multiply lang natin dun sa charge nung electron natin. Okay? So, di ba, kanina meron tayong I is equal to dq dt. Yung current natin, that's dq dt. So, gawin lang natin, substitute lang natin yung q is equal to ne. So, E is equal to, pagpalitin na lang natin, wait lang, brain ko to. Ayan. So, D, yung Q natin is NE dt, or pwede nating sabihin na, kasi di ba number of electrons per second yung meron tayo, or D, dN dt. Tama? Yung dN natin, dt, that's the number of electrons per second. And then, multiply natin yung charge na E. Nawalan ng connection. Sige. Nasusundan po? Ayan. So, we have E dN dt. So, mula lang yun dito. So, multiply natin yung charge na E or si constant 23. Pwede nyong gawin na lang sa calcu, constant 23. Times natin sa given na dN dt which is 10 raised to 15. So, ano magiging sagot dito? Paki-type sa inyong calculator.
1.602 times 10 raised to negative 4.
1.6 times 10
10 raised to
raised to
negative
negative
4.
4. Ayan, ampere. Or kapag naka-ENG, pag tiname yung ENG, anong sagot dito?
160 times 10 raised to negative 6.
Ang negative 6 ay equal sa microampere. Yun, tatandaan nyo yun ha.
Ma'am,
Okay, so meron
question
na
po ulit.
tayong negative 6, di ba?
Opo.
Apa.
Ma'am,
Tama.
question
So,
po.
yes.
Paano po ulit nakuha yung Q is equals to NE?
Nag-assume tayo na yung Q natin equal sa NE kasi 'di ba property ng charge natin kanina, 'di ba? Lahat ng charges in nature is just a multiple ng electrons. Yung charge ng electron. Kasi yung given natin dito, electrons per second kasi siya. So para makuha natin sa equation natin is yung dN dt, ito. So, kaya natin ginamit ng Q is equal to NE. Number of electrons, yung N is the number of electrons. Tapos yung E natin, diba si charge. So, yung Q natin dito is parang yung total charge. Yung total charge kung meron tayong gantong number of electrons. Nakakuha po ba?
Sige po, ma'am.
Yes po.
Ayun. So, meron na tayong I. Anong hinahanap natin, class?
Voltage.
Voltage. So, hinahanap natin voltage. Anong formula for voltage? Ang given natin, power. Tsaka, current. So, di ba? Power natin equals sa VI. So, mula dito, pwede natin gawin V is equal to P over I. Okay? So, P natin is 4 watts. No? Ito si 4 watts. Over yung I na nakuha natin, si 160 microampere or times 10 raised to negative 6. Anong makukuha nating voltage?
25,000
25,000 or 25 kilovolts.
Kilovolts.
Yes. Kilovolts. Yan. So, ugaliin natin na naka-convert na siya into engineering notation, into metric conversion, ha? Yan. Pag naka-times 10 raised to 3, that means kilo. Pag times 10 raised to negative 6, so negative, that means micro. Okay po? So, another application niya, yan, electricity bill. So, yung sa Meralco. So, pag wala kang ginagawa, tapos gusto nyo mag-compute, yun, compute nyo yung sa Meralco nyo kung tama yung kino-consume yung kuryente. So, the cost of electricity depends upon the amount of energy consumed in kilowatt hours. So, other factors that affect the cost include demand and power factors. So, we will ignore this for now kasi yung power factor is sa AC siya na topic. So, however, even if a consumer uses no energy at all, there is a minimum service charge the customer must pay because it costs money to stay connected. Costs money to stay connected to the power line. So, as energy consumption increases, the cost per kilowatt hour drops. So, we have here a table for the typical average monthly consumption of household appliances. So, yung water heater natin, ayan, ito yung mga na consume niya for a kilowatt hour. Ayan, so ang taas ng water heater. Buti na wala kaming water heater. 500 kilowatt hour yung nako-consume niya. For freezer, we have 100, lighting 100. So, ito, nagbabago siya per appliance. So, alam ko mache-check nyo siya, 'di ba? Per appliance kung ilan yung nako-consume niyang kilowatt hour. Ayan. So, is another application ng napag-aralan natin for today. Now, we have here an example. So, a homeowner consumes 700 kilowatt hour in January. So, determine the electricity bill for the month using the following residential rate schedule. So, base monthly charge, $12. First 100 kilowatt hour per month, 16 cents per kilowatt hour. Next 200 kilowatt hour per month at 10 cents per kilowatt hour. Over 300 kilowatt hour naman, 6 cents. So ito, mahaba lang siya pero madali lang naman siya i-solve. So maganda, tawag dito, ilalatag lang natin yung mga given. Okay? So yung base monthly, bakit ang sulat ko? Oh my God. Base monthly natin, $12. So, ito hindi nawawala. So, laging may base monthly charge. Tapos, di ba ang na-consume nyo is 700 kilowatt hour lahat? So, first 100 daw at first 100 kilowatt hour. So, ang price nun is 16 cents or that is 0.16 per kilowatt hour. Tapos, kapag naman, yung next 200 kilowatt hour, so that is equal to 10 cents naman. So 0.10 per kilowatt hour. Tapos, over 300 naman, so ito, di ba meron tayong 100, tapos ito 200 na, so 300 na to. 700 yung total niya, so yung natitira, 400, no? 400 kilowatt hour. So, ang magiging price na nun is 6 cents or 0.06 per kilowatt. Oh my God. Yan, kilowatt hour. So, ito, lista lang natin. Ito, $12. Tapos, ito, 0.16 per kilowatt hour times 100. Magkano yun? 16, no? $16. Tapos ito, 200 kilowatt hour times 0.10, that is
20.
20. Tapos, di ba ito, may natitira pa siyang 400 kilowatt hour times 0.6. Ang sagot,
24.
$24 naman. Ayan. So ito, pagtototal lang natin siya, magiging sagot is $72. So, ang hinahanap natin, ano hinahanap natin? Electricity bill for the month. So, ito yung electricity bill niya for this month. Pero pag gusto niyo mahanap yung average na cents per kilowatt hour. So, gagawin nyo lang yung average niya. That's $72 all over yung na-consume niya, which is 700 kilowatt hour. And that is equal to 10.2. Tama ba?
Yes po. 10.2 cents.
Yes. 10.2 cents per kilowatt hour. So, ganun lang siya. Ilibas, ililista nyo lang lahat. Nakuha po ba? Ay, ang bilis. Tapos na, oh. So, summary na. So, we have your summary. So, ayan. An electric circuit consists of electrical elements connected together. So, yun yung mga pinag-usapan natin kanina. Different electrical elements when connected together. That is an electric circuit. And we have here an SI, International System of Units. That's the International Measurement Language, which enables engineers to communicate the results. So, from the 6 principal units, meron tayong other physical quantities na pwedeng i-derive from them. Then, we have current, rate, of charge flow. That's I is equal to dq over dt. Ay, may hindi pala ako nasabi, class. Sa tingin nyo, bakit I yung unit ng current? Eh, di ba ang current naman ay letter C? Tingin nyo. May nagsabi na ba sa inyo kung ano yung reason? Kung bakit I yung ginagamit sa current? Hindi nyo ba hindi sumagi sa isip nyo? Bakit
Taken
kaya
na po
I
si C.
yun? Taken na si C outs, taken na
For
si C.
constant po.
Kasi po electricity.
Galing mo dyan.
Induction current.
Induction current. So, yung I daw kasi, parang na-research ko siya dati, yung I kasi is intensity. Ayan.
Yes po,
Just a
ma'am.
trivia. Intensity
Ay,
nung, oo,
intensity power po.
nung, nung pag-flow ng charges. Kaya ay yung ginamit. And yung C din kasi is, yun na nga, gamit na siya ni, kaninong gamit ang C? Saan ginagamit ang C?
Column.
C is unit yun eh.
Sorry na po.
So, di ba yung C natin, capacitance? Di ba? Oo.
Capacitance.
C yung ginagamit doon. Okay. Ayan, ano lang, trivia lang. So, next natin, we have voltage. So, napag-usapan din natin yung voltage that is equal to dW over dQ. Ano nga unit ng voltage natin?
Volts.
Volts. And 1 volt is equal to 1 volt equal to 1
Newton meter.
joule.
Joke lang.
Tama din naman yun. Tama din.
Per
1 Newton meter per coulomb, di ba? Tama din naman. Yan. Power natin, energy supplied or absorbed per unit time. So, meron tayong dW over dt or also equal to VI. Unit ng power? Watts. Very good. So, yan. According to positive sign convention, power assumes a positive sign when the current enters the positive polarity of the voltage across an element. Then meron tayong ideal voltage source produces a specific potential difference across its terminal regardless of what is connected to it. An ideal current source produces a specific current through its terminal naulit. Voltage and current sources can be dependent. So yung napag-usapan natin kanina, meron tayong two types ng sources, dependent and independent. So yung dependent source, it depends on some other circuit variable. Yung independent, syempre hindi nakadepende. Then, we also discussed about two areas of application, yung TV picture tube and electricity billing procedure. So, ayun siya. So, that's the end of our discussion for today.